This meeting is being recorded.
For problem 24 from chapter 3, we are given 4 pairs of compounds, and we're asked to predict which of each in the pairs is more acidic. So, and then we want to explain our choice. So let's take a look at the pair that we're given in example A here. So the difference between these two acids would be chlorine or bromine. They are in the same column of the periodic table, group 7A. So we must compare their size. Bromine is larger, it's below chlorine, so it's able to better stabilize the negative charge that would be generated after deprotonation. So we remove that hydrogen and we generate a more stable, a weaker conjugate base, therefore a stronger parent acid with HBr. So in this case, the stronger acid would be hydrobromic acid. Let's take a look at our comparison between the compounds in example B. So the sulfur and oxygen are now in the same column of the periodic table, group 6A. So again, we're going to compare their size, and sulfur is larger than the oxygen. So then sulfur can better stabilize a negative charge that would be generated upon deprotonation. So again, we would generate a more stable, weaker conjugate base, giving us a stronger parent acid with the H2S. So this is more acidic than H2O. Let's take a look at our comparison in example C. So we have ammonia and methane, and our central atom, nitrogen and carbon, they're in the same row. So now we must compare electronegativity. So we looked at size here and size here because they were in the same column, but now we must compare electronegativity between nitrogen and carbon. Nitrogen is more electronegative, so it would be better at stabilizing the negative charge resultant upon deprotonation. So ammonia is expected to be more acidic than methane. In our last example, we have acetylene here, and this is expected to be more acidic because the conjugate base of acetylene has a negative charge that would result on an sp hybridized carbon versus over here with ethine, we would have an sp2 hybridized lone pair on either one of these carbons. So again, acetylene would be an sp versus sp2 hybridized orbital. So this lone pair is better stabilized after deprotonation. So the sp acetylene would be our more acidic compound.